Hi, my name is Butch Alexa. I'm going to walk through this project with you and narrate the slides as we look at them. The project is a probe process improvement at a Midwest medium manufacturing. This is a probe. It mounts to a product and it uses Doppler technology. And what it does is it measures the velocity in the flow of a stream. So it's measuring the liquid that's passing by using Doppler technology. It's chemically resistant. The epoxy is encapsulated and withstands tough applications in many different types of streams. The probe is designed to break away if the stream is ice covered or something. When it gets going and the ice is flowing, the probe is designed to self-destruct, so to speak. It actually gets broken up with the ice and it has to be replaced. The probe is a $600 piece of equipment. The scope of the project is to reduce the overall cycle time of the probe process. The probes were running at 10 hours a day, 6 days a week, and they could not meet schedule. They could not meet what the customer needs wanted. So we were asked to look at this and figure out why they couldn't meet their schedule. And when we went back and looked at the area, it was literally jammed full of hundreds of probes in different states of assembly. So when we looked at it, we decided when we actually looked at the current state, the work in process was not the main issue. There was plenty of work in process. The assembly time was not the issue, as it met the takt time. What we found was that the time that didn't meet the takt time, the time that was impacting these backlogs, was that it was in the inspection stage and a potting solution curing stage. The inspection took 1 week, had a 95% first run failure rate. At the second test, at the retesting, they had a 100% pass rate. That was a 2-day test. And so right away you start to wonder, why are you doing a 5-day test with a 95% first run failure rate, and we have a 100% pass on a second test, which is a 2-day test? Kind of a moment to go, The potting solution takes 24 hours to cure. That puts everything back 1 whole day. Here's the current state spaghetti diagram. The raw materials come in, it goes to an operator that assembles it, puts it together. It goes then to the curing or the molding where they pot the solution. The Doppler unit gets potted into the end of the probe, and then it gets put into a room where the mold filling is going to be cured. It sits there for 24 hours. When it comes out, it goes into the float tank. It's a big tank where these get hooked into a master test unit, and tests are run on it while it's submerged in the tank. They keep it submerged for a week to see if there's any failure in the potting solution. Once that is done, comes out, it gets a final inspection, a final covering, a final assembly, and then it goes out the door. So after looking at the process and analyzing it, the throughput was low due to bottleneck rate located at the drift test and curing operation. The failure rate of the drift test was due to the tank being situated next to the main aisle, and when the forklift trucks drove by, it interfered with the test. So pretty much every test they ran, they would start a test on Monday and they would run it until Friday. And pretty much every one that was run in that tank during that week failed. What happened is then they would come in, they would take the retest, and it was done on Friday night until Monday morning, a 2-day. Well, the reason it passed 100% was there was no forklift traffic. There was no vibrations, nothing. Nothing was done. So you have to look at that and say, why are we doing 5 days versus 2 days, first of all? And then why would we have the drift tank next to a forklift aisle? So we discovered this, and we found out that the throughput and the cycle time are running close to worst case scenario. We decided something must be done. Only way to improve the throughput and cycle time is to make changes in the process itself. So with all that being said, we looked at this and said, ensuring quality inspection should never be a means of assuring quality. Inspection is a sorting process at best. Good parts versus bad parts. Inspection never adds any value to any process. I know some of you are going to go crazy with that statement, but tell me what happens when you're inspecting it. You're adding no value to it. It's a non-value added activity. We need to rethink this inspection process. Inspection adds variability to the system. That means every time I touch a part, I'm introducing variability to the system, and variation causes defects, and defects, Variation is the enemy. So in order to ensure quality, we want to use process capability analysis or control charts. That's what we want. We want to create control charts for this process. We want to determine the inspection needs from the results of the statistical process control. We don't want to just haphazardly say, we're going to check every part. 100% inspection is only 85% effective. 200% inspection drops it down to around 60%. Our assumptions at this point was that every probe will not need to be tested. Their concern was getting a bad probe out to a customer. So they tested every probe, and yet they still had probes coming back that were bad. Their fear of getting probes out to the customer that wasn't working was creating part of the problem. So the inspection may be able to be redesigned to reduce cycle time and increase throughput. We talked to engineering about this, and we put that into play. The bottleneck at the potting solution curing station needs to be improved. There is no question that the bottleneck at the potting solution of 24 hours, we have to reevaluate that. So what we did, here's the actions we took. We eliminated the drift test, which automatically improves our throughput by doing two things. We did two things here. First, we relocated the drift tank, and we reduced the amount of time in the test tank so that we could get increased throughput immediately. By moving it away from the main aisle and cushioning the drift tank from vibrations, we actually got up to almost 100% accurate test. If there was something that failed, it was an assembly issue and not the environmental issue. The second is that by introducing SVC to the process, the ability to detect any assembly errors was actually increased as process capability is measured and monitored. So what we did here was we moved the drift tank, we introduced SVC so that we could look at process capability. We went to a 2-day test. We were already doing it. We went to a 2-day test. It increased customer satisfaction and throughput immeasurably. Then we looked at the potting solution. We reviewed with the manufacturer the potting solution, and an updated solution was decided upon so that when we assembled them and put the potting solution into to protect the Doppler units, the solution only required 15 minutes of cure time, 15 minutes versus 24 hours. Big improvement. Now we're starting to see that we can meet takt time and we can actually improve our process overall. So the conclusion was that by testing versus not testing, by going from 100% testing to 0%, that meant we're doing 100 probes in 30 days. If we go to 0% testing, meaning we're going to utilize SVC charts and do random testing, we went from 0 to 100% not tested. We increased our throughput to 280 probes per day. This meant that by increasing it, the profit gain per month was $43,200. We also reduced our returns from the probes that were no good as they got into the field. We met customer needs, we increased throughput, we increased reliability. It's a win-win all the way around. Again, my name is Butch Alexa. I hope you enjoyed this. It was an actually true case. Take care.